A nightly reindex is too late for fresh search. Kafka and OpenSearch let Python stream document updates into the index as they happen. You'll learn how the pieces fit into a workflow that consumes change events and refreshes search results incrementally. I'm Professor Pi, teaching Search and IR with simple Python. Search users expect changes to appear fast. Product updates, profile edits, and moderation actions should show up in search within seconds, not hours. A full reindex is heavy, slow, and often unnecessary. Incremental indexing sends only what changed, keeping latency low and costs predictable, while your index stays accurate for live queries. The idea is straightforward. Capture change events as they happen. Buffer them so you don't lose or double apply updates. Collapse duplicates so only the newest version per document moves forward. Push those upserts into OpenSearch with a short refresh so searches see the new state quickly. Each piece trades throughput for freshness and changes how failures are handled. We'll build a tiny end-to-end demo. It publishes deltas, consumes them reliably, deduplicates to the freshest version, creates a fast refresh index, bulk writes, and then verifies the results in search. Nothing fancy, just the pieces you need to understand the incremental loop. Quick note, this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. Now we publish a couple of change events that represent 2 document updates so we can exercise the whole pipeline. This snippet publishes 2 JSON document deltas into Kafka. Fresh search relevance starts with timely change capture. So event batch threads doc ID and version fields that later gate merges in OpenSearch. Producer.produce pushes each JSON dumps payload into Kafka topic, while Kafka Bootstrap keeps the endpoint consistent for future consumers. Producer flush blocks until the broker accepts the batch, preventing phantom gaps that would whipsaw downstream freshness metrics. The event's published count confirms the queue now holds every stage change we plan to replay. With messages in the queue, we need a consumer that controls when offsets are committed, so we never mark work done before OpenSearch accepts it. Here we drain the topic into a manual buffer and hold acknowledgement until we are ready to index. This example drains Kafka into a manual delta buffer so we can control acknowledgement timing. Stale replays happen when offsets auto-commit before OpenSearch writes, so consumer uses enable.order.commit false and waits on Kafka topic explicitly. The loop polls with a 1-second timeout and appends decoded payloads into delta queue only when msg.error is clear, keeping only the clean events. Once len delta queue hits the target, consumer commit seals the offsets and the connection closes to release resources. The delta's buffered total shows we captured every update exactly once before touching the index. Buffered deltas still contain multiple updates for the same document. We must reduce them so only the newest version per ID goes forward. That keeps writes minimal and the index consistent. This code reconciles buffered deltas so only the freshest version of each document reaches OpenSearch. Duplicate doc ID updates are a classic reason search returns stale snippets. So latest versions tracks the best candidate per key and overwrites older entries whenever a higher version value arrives. Sorted docs then orders the survivors by version and doc ID, which gives deterministic processing even when several topics race in. The docs ready list shows exactly which document IDs will flow forward and in what order the incremental upserts will run. Before indexing, we want an index configuration that makes new documents searchable quickly. A too slow refresh interval defeats the whole point of streaming updates. This snippet provisions an OpenSearch index tuned for fast incremental refresh. Without a short refresh interval, pipelines finish yet searches lag, so mapping sets index refresh to 1 second while configuring minimal field types for title and version. OpenSearch client.indices.delete wipes any prior test index, so incremental runs never inherit broken settings, and indices.create rebuilds the target in a few milliseconds. The index ready flag proves the cluster accepted the configuration and is standing by for updates. Finally, we push the cleaned list into OpenSearch using the bulk API and immediately validate that the documents are visible to queries. That closes the loop back to search. This example pushes the deduplicated docs into OpenSearch and immediately checks search freshness. Actions builds bulk index operations keyed by doc ID, so reruns overwrite stale records instead of fanning duplicates across shards. Bulk OpenSearch client actions refresh equals true commits the batch and forces visibility, while the match all query reads back the top results without waiting on background refresh. Collecting fresh docs from the hits payload confirms both documents are live with the latest version numbers, meaning the end-to-end incremental loop is working. Mapping this small flow to a real product catalog is straightforward. Swap the simple JSON deltas for your change data capture stream. Apply the same deduplication when multiple systems touch the same product. And run the consumer with commit on success so your index stays in sync without losing messages. In short, this is an event-driven incremental indexing loop that keeps search fresh when updates arrive continuously. Use it when users need near real-time results. And remember that shorter refresh intervals increase write and compaction overhead, measure resource use. A practical next step is to tune two knobs on your real dataset. Adjust the bulk batch size and test refresh interval values starting from 1 second to find the best latency versus throughput point for your product feed. Run that test on a representative set of updates and watch indexing latency and search visibility. If practical search engineering helps you, subscribe and watch the IR videos.